Now we are going to discuss about endocrine system. Human endocrine system and its coordination by hormones. We will discuss here. So we know that all functions in the human body are coordinated and regulated in order to maintain homeostasis. So we know about neural system. So we studied that neural system, it provides a point to point connection and rapid coordination among organs. So but this neural coordination is very fast and sharp lived. Even nerves do not innervate all the cells of the body, but cellular functions also need to be continuously regulated. So for that, a special kind of coordination and integration has to be provided to the body. So the cellular functions are regulated by a special kind of coordinating system in our bodies with the help of hormones is called endocrine system. So when we compare to the nervous system, the endocrine system is slow, but it is long lasting. The hormones should release from the endocrine organs into the blood circulation. That hormones reach to the target organs, there it will be functional. So even we can say the principal role of endocrine system and neural system both helps for the coordination and control of major physiological functions of the body. So it should control and coordinate major physiological functions or all the physiological functions of the body. So we can say both are playing an important role for coordination. So here we will discuss about endocrine system. So endocrine, the word endocrine means it is generally derived from Greek endo. That means internal, inner part. Endo means inner and crine means away. You can tell functions away from the secretions. reached to the target organs mostly. It's released at one side, reached to the another side. That's why away from this releasing site. So this endocrine system in human body contains tissues, organs. The tissues, endocrine tissues or endocrine cells are organized to form endocrine organs. So that tissues and the organs present in the endocrine system together called endocrine glands. Endocrine glands are present. These endocrine glands and the secretions of endocrine glands together, we are telling endocrine system. Generally, we know that exocrine glands, endocrine glands, exocrine glands having ducts to carry their secretions, but endocrine glands have no ducts to carry their secretions. That's why endocrine glands do not possess ducts, which do not possess ducts to carry their secretions. So we can say endocrine glands are ductless glands which do not having ducts to carry their secretions. So we can say ductless glands. See, once again, endocrine is a word derived from the Greek words endo, which means inner, crine means away. Endocrine system contains discrete tissues and organs together. Endocrine glands and their secretions are called as endocrine system, which do not possess any ducts. Ducts are absent, hence endocrine glands are ductless glands. That means their secretions directly are released into specific cavities, or their secretions directly released into bloodstream. So endocrine glands secretes hormones. So the secretions of endocrine glands are called hormones. So these hormones are released directly into bloodstream. These are released directly into bloodstream. Especially we can say a bloodstream means venous blood. released into venous blood. So we can tell hormones released into body fluids. The body fluid may be venous blood or released into lymph also. So through this body fluids circulated in the body, through these it reached to target organs. Through the blood or lymph it reached to target organs or target tissues or target cells, whatever it is. So through blood reached to the target organs. Target organ means the hormone are specific to act on specific tissues or organs, released at one site, reach to another site to becomes functional. That's why the hormones are specific, which show specific functions on the specific organs. You can tell that are target organs. So hormone means they are telling hormone is a word which is first introduced by scientist Starling. According to him, hormone means non-nutrient chemicals which do not provide any nutrition and which do not secretes more and more also. Very less amount of hormones are secreted. The quantity of the hormone is very trace amounts and which act as messengers. So according to that, hormones are non-nutrient chemicals. Hormones are non-nutrient chemicals which are acting as intercellular messengers which act as intercellular messengers, not intracellular messengers, which act as intercellular messengers and are produced in trace amounts. The secretions are very less. That's why less quantity, very trace amounts are produced from the endocrine organs or cells, produced in trace amounts. So, like non-nutrient chemicals act as intercellular messengers and produced in the trace amounts, not too much quantity. So, we are telling that the term hormone was coined by Starling. Starling coined the term hormone. And secretin was the first hormone to be discovered. The first hormone which was discovered is secretin. Secretin, generally it is secreted in the gastrointestinal tract from duodenal cells. It was the first hormone. First hormone to be discovered is secretin. So we are telling that hormones acts as messengers which acts on target organs. So target organs mostly away from the site of production, but some hormones may act as local hormones, that means which is secreted and acts in its site of secretion. So that's why you can say most of the hormones, mostly hormones secreted at one site, reached to the target organs away from their secretions. That means their secretion is one side and functioning is another side. Exception are there for this. Some local hormones which are secreted and acts on the target organs in its site of secretion. Local hormones are exceptions from that. Some local hormones includes gastrin, gastrointestinal tract secretes gastrin hormone in the stomach, like somatostatin, are local hormones secreted and functioning in its site of secretion. See once again, secretions of endocrine glands are called hormones, released directly into blood or lymph, reach to the target organs through blood or lymph, and this hormone is a non-nutrient chemical which act as intercellular messengers and produced in very low amounts, trace amounts. This hormone is a term coined by Starling, and the first hormone was detected is secretin in our duodenum of gastrointestinal tract, and mostly hormones secreted at one site reach to the target organs for its function, but some hormones act as a local hormones like gastrin, somatostatin, which released and the function in the site of secretion only. Here, hormones function is to coordinate the physiological functions or accelerate the functions or inhibit the functions of the body. So we can say hormones coordinate, accelerate, or inhibit one or more functions. So the hormones are small sized and effective in low concentrations, even the secretions are very less, but which are effective even in very low concentrations. Hormones are chemically smaller size, biomolecular size is small, small size and are effective in very low concentrations. Most of the hormones are specific. I said that highly specific regarding their target organs. Most of the hormones are highly specific regarding their targets. That means we can say thyroid stimulating hormone. It is a hormone from the anterior pituitary axon, thyroid gland only. It is the hormone and it is the target organ. Target organ for this hormone is thyroid gland. Like adrenocorticotropic hormone. So this hormone released from the anterior pituitary for this target organ is adrenal cortex or adrenal gland. So the target organ for this is adrenal gland. It is the hormone These are the target organs. So released from one site, reached to another site for functioning. So most of the hormones are specific, mostly, except a few like growth hormone. For growth hormone, target organs are not specific. Mostly acts on almost all the somatic cells. Growth hormone have no specific target organ. Specific target is not there for growth hormone. So mostly hormones are specific to functioning, which acts on specific target organs. Like we can say thyroxine hormone. Thyroxine hormone also mostly acts on all somatic cells, no specific target organ. So target organs are mostly present to the most of the hormones, but some hormones have no specific target organ, mostly acts on all somatic cells of the body. And here, hormone secretions also based on the quantity of secretions. If any hormone secreting more or any hormone secreting very less, that means less than its normal. That means normal secretions do not cause any effect, but over secretions, over secretion of any hormone or under secretions, lower secretions of any hormones. So we can tell hyper secretions or hyposecretions. Hyper secretions, hyposecretions causes disorders. Disorders due to hypersecretions or lower secretions. So we can tell that hormones, once it is reached to the target organs, and mostly that are degraded by the tissues and excreted through bile and also through kidneys through urine. So like we can say about hormones, its chemical nature makes the hormones classified into different types based on the chemical nature or chemically hormones are classified into amine or amino acid derivative hormones, peptide or protein hormones, steroid hormones. So mostly hormones are three types based on the chemical nature. We'll see that also. Right. See, chemically, hormones classified into three types that are amine hormones, amino acid derivative hormones. So, which are derived from the single amino acid, like peptide and protein hormone and glycoprotein hormones also we'll see here. Steroid hormone. About these types of hormones we'll discuss. First one, amino acid derivative hormones. Hormones derived from the single amino acid. The hormones derived from single amino acid. You can say that are amino acid derivative hormones. So example, we'll say catecholamines. Catecholamines are adrenal medullary hormones like adrenaline or noradrenaline or epinephrine, norepinephrine. One more, thyroxine. Thyroxine also derived from the single amino acid like melatonin. So these two derived from the one type of amino acid and this is derived from another type of amino acid. So catecholamines thyroxine derived from the amino acid called tyrosine. Tyrosine is an amino acid. Thyroxine and catecholamines derived from the tyrosine. And melatonin derived from the one more amino acid, tryptophan. Tryptophan, melatonin derived from the amino acid tryptophan. So single amino acid derivative hormones, catecholamines, thyroxine, melatonin. And then peptide hormones and protein hormones. Peptide and protein hormones. Let's see here. So we can say that polymers of amino acids, polypeptide chains forms the hormones here. So the polypeptide chains may be small peptide hormones and long peptide hormones. Small peptide hormones contains amino acids from the range 3 to 49 amino acids. Long peptide hormones ranges from 50 to 200 amino acids. So, small peptide hormones, long peptide hormones. So, long peptide hormones, small peptide hormones, alternatives, protein hormones. So, small peptide hormones, almost hormones from the posterior pituitary gland, like ADH, antidiuretic hormone, oxytocin, are small peptide hormones. Antidiuretic hormone, oxytocin, together considered small peptide hormones. And remaining hormones, like almost anterior pituitary hormones. Anterior pituitary hormones are long peptide hormones and hormones from the pancreas, pancreatic hormones, long peptide hormones, parathyroid hormones, parathyroid hormones. These all are long peptide hormones, protein hormones. In this anterior pituitary hormones, some protein chain also having a side chain like glycoprotein hormones. A side chain of carbohydrate is present to the protein, like for follicular stimulating hormone, luteinizing hormone, thyroid stimulating hormone, which having carbohydrate side chain. Carbohydrate side chain is present, you can say that are glycoprotein hormones. So that are protein hormones. And then steroid hormones. Steroid hormones made up of cholesterol derivatives. These are derivatives of cholesterol. Derivatives of cholesterol. Which includes so many hormones like aldosterone from the adrenal cortex. Almost adrenal cortex hormones are steroid hormones only. like testosterone, progesterone, estrogen, cortisol. Even you can say cortisol also adrenal cortex hormone. All adrenal cortex hormones and the hormones from the gonads are steroid hormones. Along with that, prostaglandins. Prostaglandins are derivatives of eicosanoids, which are derived from the essential fatty acids like omega 3 and omega 6 fatty acids. So, prostaglandins, derivatives of eicosanoids, derivatives of eicosanoids, eicosanoids. That means eicosanoids means you can say derived from the essential fatty acids. Derived from essential fatty acids. That omega 3 and omega 6 fatty acids are essential fatty acids from which eicosanoids are derived, from which prostaglandins are derived. Okay, so like we'll see about hormones based on chemical nature. Hormones are classified into amino acid derivative hormones, peptide and protein hormones, and steroid hormones. Okay, thank you.